approach of understanding this chapter or any chapter will be different. So the first thing first, we will try to define what kind of progression will be called arithmetic progression. Okay. So I don't think I need to explain too much to you. Any series which grows with a consistent or common difference will be called arithmetic progression. So like if I have written a series 5, 8, 11, 14. So what we can see here is that every consecutive term is growing by, the next consecutive term is growing by 3 only. So there is a common notation to represent few things here. If you are representing the first term, if the series is getting started from a particular term, the first term will get represented by a letter A. The difference by which the series is growing or building, and it may be negative also, like there can be a series like this. So what do you see here is that the common difference between two consecutive term is -2. So the common difference term will be denoted as D. Okay. And any particular term like seventh term or nth term, nth term will be represented as Tn. Likewise, if I am representing third term, I will call it T3, and similar. And if we are calculating the sum up to n terms, sum of all terms till n, it will be represented as Sn. So these are the representations related to arithmetic progression. Okay, is it clear to everyone? Now, if
Yes, sir.
there is a series, and I'll take the same series which are there, you can easily see that if the common difference is 3, the second term I am getting by adding 3 to the first term, 1 time 3. The third term I am getting by adding 2 time 3 to the first term. So what I'm trying to do here is I am trying to represent all the terms with respect to first term only. So for the second terms, one common difference has been passed. For the third term, since start, two common differences have been passed. For the fourth term, it will be 5 plus 3 into D, and so on. Sorry, 3 into 3, and that is D also. So what you can easily see here or observe here is Tn is equal to nothing but A into n minus, sorry, A plus, it is n minus 1 time common difference more than first term. So I'm speaking it also n minus 1 time common difference more than first term. So this is my general representation of general term or algebraic representation of general term. Now there is a problem, or not the problem. Now if we need to find that whether a particular number will lie on this series or not. So let's say I have a number 213 and I need to check that where whether this particular term, not 213, let's say it's 212, whether this term lies on this series or not. And with I'm just writing the question form. Uh, is 212, yeah, does 212 lies on the series? Second, if yes, at what term? What will be the value of n, or which term is that? Okay, so I have two questions. So what I know is that every term is certain times common difference more than first term. So that means if I'll get the difference between this and 212, it must be or it should be divisible by 3 in order to make sure that whether this term lies on this series or not. So 212 minus 5 is 207, and 207 is divisible by 3. Uh, so I can make sure, or I can confirmly say that 212 will lie on this series. And if it is lying on the series, which term is this? So you don't have to use formula, this formula, like the formula says Tn is equal to a plus n minus 1d. So if you'll ask somebody to calculate which term is this, so what they will do is 212 is equal to 5 plus n minus 1 into 3. And they will solve it for n. But you don't have to do it. You just need to find out how much common difference away from first term it is. Of course, I am doing the same thing which is written here, but in language format. Okay. So since, and we have already divided this, so it is 69 times common difference more than first term. So it must be 70th term of the series. Is it okay to everyone? बताओ, समझ में आया सबको?
Yes, sir.
So let's take another example. If there is a term like 3, 8, 13, 18, and this, and somebody asked whether 353 or no, 355, whether this term lies on the series, or if it is not, of course it will not lie on the series. Nearest number to 355 which lies on the series, which will lie on the series. So again, what I'll check with how much distance it is away from the first term. So I can just find the difference. It is 352 and the common difference is 5. It is not divisible by 352, but the remainder is 2. So if it is not divisible, this makes us to say that 355 will not lie on this series. And this 2 will actually help me to find the nearest term of 355 which will lie on the series. So I know whether I'll remove this 2. So if I'll remove this 2, I'll get 353. And we can also complete this for common difference. Our common difference is 5. So this term will also lie on the series. So out of these two terms, whichever is small, you can just tell. Sometimes you need to find this, not this. So this is how we calculate the general term or the nth term. And you can also calculate the nth term. Everybody knows now how to find nth term. Like for this series, the series which is here, if somebody is asking find the 10th term, so how will you find? You will add 9 times common difference more, or you will make 9 times common difference, add 9 times common difference to the first term. So 9 into 5. So what I'm doing, I'm actually using the formula only, but it is in my mind. I'm understanding that what I'm doing. I'm not just calculating it. Okay. Next problem is finding the sum of an term. So for a formal understanding like aptitude wise understanding, I'll be using average to find the formula of any arithmetic progression. So just remember the chapter of average. There we studied that for any arithmetic progression like 2, 4, 5, 2, 4, 6, 8, 10, the middle term is your average, for any arithmetic progression. And average is something which can replace all the numbers without changing the total. So the total for this series and total for this will be same. This is by default coming from the definition of average. So if you want to find the sum of this series from 2 to 10, you will just multiply average with number of terms, and here in this case 6 into 5. So I'll be using the same thing here. Let me uh, let me write the AP in this way. Let AP is starting from A. The next term is A plus D, and so on. The nth term is A plus n minus 1D. Everybody knows this. Sometimes, if nth term is last term, we call it L. So, the average of all these terms will be the center value, which will be A plus L by 2. And if you want to find the sum of this AP, and I know how to represent the sum, Sn is equal to average into number of terms, or we can call it vice versa, number of term into A plus L by 2. Or we can rearrange the terms as n by 2 into A plus L. So this is one way to represent. Another way to represent will be writing the L in its common or general form. So what I'll do here is I'll write the same sum n as Sn as n into first term A plus nth term, which is A plus n minus 1 t, and divided by 2 because we wanted to have the average of the series. So this can be written as n by 2 2a plus n minus 1d. Okay, this is your formula. And you could have also derived the same formula by writing all the terms as this. T1 is equal to A, T2 is equal to A plus D, T3 is equal to A plus 2D, and so on. Tn is equal to A plus n minus 1t. So if I'll make the sum of all these, it will be represented by Sn, and because there are n terms or A is being used all the n times, so n into A plus, you will take the common D and you will be left with 1 plus 2 plus 3 and finally n minus 1. So n a, and you know how to find sum of n natural numbers. So n minus 1 into n minus 1 plus 1 divided by 2. So by this way, you will be getting actually same. So using average, it will be much better and easier. And if you'll remember the use of average, or if you'll find the use of average, you will not have to remember the formula, even use the formula in any case. Like, let me give you an example. 3, 7, 11, 15, 19. If there is such series, so definitely this is an AP. And if somebody said to you that find the sum of Tn plus T11 plus all the terms till T20. Okay. So if you want to calculate this sum, and if you remember what you have been doing, or what you could have done when you were in a school, you would have calculated the sum of all 20 terms, and then you have uh, reduced reduced it by sum of 9 terms. So that's how you have calculated this. Because the only formula that you know is this one, which was written there. So this would have been a very peculiar task. First find the sum of all 20 terms, then find the sum of 9 terms, then reduced it, and then you will get the all sum of all the terms from 10 to 20. But now, since you know that AP is always in AP, and either you take it from the first term or the 10th term, and if it is there, the average term will be which one? Which one will be the average term? 15th one. So I know there are total 11 terms here. And from 10 to 20, how many terms will be there? From 10 to 20, how many terms will be there? Anyone?
11.
11. You should never say 10. I'll give you a very small line to remember. Total number of student. Always remember, this is a big catch. Every time you'll be get stuck with this, and you might solve a particular question wrongly, even if you know the proper solution of that. Total number of students from roll number 3 to 11. ये कितने होंगे? कितने students होंगे? How many students will be there from 3 to 11? Never say 8.
9.
Yes. Because the 3 will also get counted, because the number of students are being asked 3, 4, 5. So 3 is being counted. So it will be 9 always. So the total number of terms here is from T10 to T20 is 11. And the central term is your T15. So the sum of this would be T15, which is the average, and into 11, which is number of terms. This was my average, and this was number of terms. And you know how to find T15. So T15 is 14 time common difference more than first term. So the common difference is 4. 14 time common difference is 14 into 4, which is 56, plus A. So 59 is the 15th term, and 11. This will be your solution. Now you might ask, sir, you have taken all the things as integer. What about if the total number of terms for the same series? If someone is asking that find the sum of T31 to T40. So here there will be a problem for you, that you won't have a term as its average value. So here, and but the total number of terms will be 10. So in previous case, T15 was the average, but here there is no term which will be acting as average. So actually you have to find the average. So you can do two things. Either you can calculate T31 and T40 and find the average by adding these two by 12 by 2. Or you can just locate the average. So if we'll try to locate the average will be T35 between T35 and 36. And I know the gap between these two will be 4, because the common. So I can directly find T35, which is 3 plus 34 into 4, which is what? 136. 3 plus 136. And this will be your 35th number. And you just need to add 2 into it because the average will be the mid of this. So I'll just add 2 into this. So this will be the average value and I can multiply it by 10 to find the sum. So it will be 139, 141 into 10. This will be the sum. So these few things were very important, and all the questions can be solved through these logic only. And there is one catch which is frequently asked, and this is like extension of this chapter. And actually, uh, we have seen that every year or every in 2 year, there will be one question based on this. First, but there's on two things. First, if Sn is 0 for any particular AP, that means the AP will have few terms and 0 will lie exactly between them. So if a six term AP is there, 0 will not lie on this AP. But if S6, and if S7 is 0, if anybody is saying S7 is 0, this suggests that T1, T2, T3, T4, T5, T6, T7. If sum of these is 0, the middle term must be 0 because the average value must be 0. So T4 will be 0. So all of a sudden, if somebody is asking that S35 is 0, I mean, total sum of all 35 terms of an AP, first 35 terms on an AP is 0. This actually suggests what? T18th is 0 because 35 is odd number and the average of all these 35 terms will be 18th term of that AP and it must be 0 because sum is 0. And if 30 S34 is 0, then we can guarantee or we can take the guarantee that 0 is not lying on this AP, but 0 will be between this AP on what term? T17 and T18. Between T17 and T18, 0 will lie. So this particular thing was not that important to tell you here because you could have developed this while solving problem only. And there is one more thing. Let's say if T11 is 19 and T19 is 11 or, or any similar series. Let's say T24 is 5 and T5 is 24. So you can just see that the 11 is the smaller term and 19 is the bigger term, and the term is basically getting reduced. Here, the from T5 to T14 term is getting reduced. So any such case can only be possible if common difference is -1. So I'm just giving you this idea. You can explain or you can think on about it that how it is happening. So any such situation is there if someone is saying that Tm is n and at the same time Tn is m, where n and m is natural numbers. Okay, natural numbers. N and m belongs to natural numbers. In such cases, so it is basically the same thing. Here also the common difference is -1. So you can just think through it and find how it is being how it is true. So this is the part of the AP part gets over here. In next class, we'll be learning GP. I wanted to teach you GP also tonight, but I'll give you some time to solve question based on AP. Next class, we'll have the doubts on AP, and we will also also explore GP. You know? And GP is important. It is being used in many chapters. The infinite term or infinite sum of GP when common ratio is less than 1. I should not be speaking that right now. So this is for now, but I'm not stopping the class. I'm just stopping.